In this lecture, we will study the different characteristics of the actuators. Before that, we'll quickly recall what is an actuator. So actuator, it is a device that does the physical work after the sensing and the decision making. So the sensors will sense, then the processor will decide, and then the actuator will act on that. Some examples of the action of the actuators are the motor opening a door, then valve controlling water flow, fan switching on and off automatically. Now here there are four characteristics of the actuators. First is the weight, then you have power rating, torque to weight ratio, and the last is stiffness and compliance. We will have a look on all of these one by one. First we'll see what is the characteristic, that first characteristic, that is the weight of the actuator. Now the physical heaviness, it will decide where these actuators can be used. That is why the weight matters now, because heavy actuators, these are very strong, but these are very difficult to move, and light actuators, these are easy to move, but those will be having very limited strength. Some real-time examples are, you have industrial robot arms where those uses heavy motors because they stay fixed and they will lift heavy loads. Car power windows, those will use the medium weight motors. Okay, and you have drones which use very lightweight motors in order to reduce the battery usage and also to improve the flight time. Then you have aircraft landing gear motors which are very heavy, but still those can be used in the mobile systems because the strength is critical. So weight affects the portability and the application type. Next characteristic is the power rating. The power rating will tell us how much voltage and the current an actuator can safely handle. So if we apply more power than the rated one, the actuator gets overheated, it may also get damaged, or it may get burnt out. Now some examples, real-time examples, are the small servo motor which can be used in the toy or the hobby project, where it works at a 5 volt and a 500 milliampere current, and it is powered by the batteries or the USBs. One more example is the automatic gate motor, which works on 230 volts AC or 460 volt AC, and it needs a dedicated power supply. And one more example is the industrial conveyor motors, where those requires very high voltage and current, and those cannot run on small batteries. So the power rating decides the size of application and also the power source. Next you have the torque to weight ratio. This torque to weight ratio, it will tell us how effectively an actuator can rotate or move a load compared to its own weight. Okay, that is in easy words you can say that if the torque is very high and the weight is low, then it is very efficient actuator. If low torque, high weight, then less sensitive and slower actuator. Some real-time examples are the robot arm motor, where it needs high torque in order to lift the objects. You may have, second example is a ceiling fan, where it requires low torque but the constant motion, and servo motors in robotic gripper, where these will be having very small weight, high torque, and these are very precise in control. And the last is the electric bicycle motor, where it is designed to give very high torque with limited weight. So better the torque to weight ratio means better performance. And the last characteristic is the stiffness and the compliance, where the stiffness refers to the resistance to bending or the deformation, and the compliance is the ability to bend or adjust under the force. So now why it matters, why the stiffness and the compliance matters? Because the stiff actuators, these are very fast and accurate response, and these are having very fast and accurate response, whereas the compliant actuators, these are very smooth and flexible response. Some real-time examples are the hydraulic systems such as the Actuators and the lifts, where those are very stiff and those require very high accuracy and the power. Then second example is pneumatic systems, where we will be having the air brakes or the air cylinders which are very compliant, and these will absorb shocks and these are having very smoother motions. And one next example is the human muscles. So here these are naturally compliant, that is these are having very safe interaction. And one more is the robotic soft robotic grippers, where the compliant to avoid damaging objects. Okay, these are compliant to avoid damaging objects. So stiff is nothing but the precise and fast, whereas compliance is the flexible and safe. Okay, so stiff is precise and fast, compliance is flexible and safe. So in one word you can say that weight, where the actuator can be used, and the power rating is how much power it can handle. Torque to weight ratio is how strong and efficient the actuator is. Stiffness and compliance is how accurately and smoothly the actuator responds. So these are the characteristics of the actuators. Thank you.